is talking about CloudStack, building your own cluster for $500. You can build it on the cheap. I'm sure there's quite a few people in here that have their own home servers that are running or have run in the past. This is something very, very doable. First, some about me. I am the IT for my house, as I'm guessing there's a few other people here. I generally program. I've been doing software development for well over 20 years now. So I am the one that fixes the servers or the computers or the internet or whatever breaks at home. There was a time I worked on implementing an MLS trusted operating system and also implementing a system that ran on trusted operating systems. For those of you who have done that, you know that sort of screws up your view of security from there on. But that's not what this talk is about. This talk is about CloudStack and what I did to build a small, useful set of cluster, small, useful cluster for less than $500. I did this quite a few years ago. This is actually a updated talk that I gave at ApacheCon a few years ago about this exact subject, same talk. So now, why would you want to do this? First of all, I just wanted to see if it was possible. If it was possible to actually, no, it doesn't work at all. If it was possible to build a cluster that would be useful for $500. Could you get it? Would it be able to do any useful work? Could you keep it that cheap? And you can. I've been using AWS private clouds for quite a few years before this. And wanted to have some other. Sorry about that. Some other. Can people hear me still? Okay. I can't tell from back here whether you can hear it or not. So I wanted to see some other clouds to see what actually underlied the cloud, kind of those old hardware architecture classes that I was required to take in comp sci. Because to really understand how it works, to see how it works under the hood is really, really helpful. So that was one of the reasons. It matched up with a proposal at work. So because of that, I picked CloudStack, was one of the reasons I looked into that. Of course, just it seems fun because running your own server, whether it's Plex at home or Squeezebox or an AS or your own DNS or whatever it may be, sometimes for a lot of us, that's something that's really fun to do and to have enjoyment doing that. So that was another deciding factor on why I wanted to try to do this. And then when I actually got it running, it turned out to actually really be useful for some of those side projects you're doing at home, or maybe that learning of a specific distribution to take a look at so you can have a more informed opinion about it. So why exactly did I choose CloudStack? It's open source, which is definitely something I think a lot of us would be a key deciding factor. It's probably one of the simpler full clouds you can deploy. OpenStack seems to have improved that recently. There are other solutions like Proxmox that aren't quite a full cloud. CloudStack is a full cloud. It's used in production for some pretty large numbers, especially in Europe. So that's one of the reasons I picked it. As I was mentioning earlier, it matched up with the proposal I was doing for work, and I figured might as well just get an early start on it. And as I was mentioning before, I really wanted to use a different cloud because all the clouds are slightly different, and having a wider range, especially as we're moving into a multi-cloud deployments, is really helpful. So what are my requirements? Requirements are obviously as cheap as possible. The CPU must support 64-bit with VM extensions. That's required as part of CloudStack's requirements. I figured a minimum 2 nodes before it would be really useful. So I'd need at least some storage, something to manage it, and then a compute node. Even though there are quite a few options for CloudStack for storage, I chose to do NFS, figuring that that would be the easiest, most straightforward to do it. But there are a lot of other options. You can pretty much any storage you can run under CloudStack if you want to. I was targeting to be able to run about 3 to 5 instances. The more would be nice. And figured a reasonable amount of memory for doing that was 16 gigs. And so that's where I started. So what am I not counting for that cost in here? A big one is the network switch. I had just done an upgrade at home, and I have plenty of ports. I still have plenty of ports. So I did not count that. But you can reasonably get a 2 or 3 port switch for this to dedicate without too much trouble. I also did not buy cases, as you can see as an example of what I built. It's just going to sit in the closet. It can look ugly. I took, as you can see, quite a bit of inspiration from some of the minimalistic crypto rigs that you see out there. And I had lots of scrap wood, so I just stuck it together, attached stuff as needed, and that has actually worked out really well. It's held up fine. I've had to move those servers a couple of times to reinstall OSs or to upgrade hardware because hard drives failed or whatever. It has been no problem. So what is the process about doing this? First, I started with the CPU. What was the minimal CPU that I could find that would meet the requirements? Find the cheapest motherboard that would meet the requirements. Find the cheapest memory without too many DOAs. If you look on whether you're looking on Amazon or New Cloud or whatever your preferred place is, usually you can see the reviews there and have some idea how many are being returned. I chose, I could have gone cheaper with memory, but it just wasn't worth the hassle of DOAs. So then I just found a cheap power supply, looked at this, is this reasonable? A couple of times I looked at it, I'm like, yeah, I don't think this is reasonable. It's not either not going to have enough power, or it was going to be too noisy, or any number of other reasons. So then I started over until I found something I thought was reasonable. And then I just picked the biggest hard drives that fit within the budget. So that ended up with 250 gig hard drives is what I started with. That's not what it is on now. It's now an SSD is about the same size. Cheap hard drives fail even more than other hard drives do. So this was originally ordered in the fall of 2017. So it came to $487.52. And I've looked a few weeks ago, and you can get something pretty close to this or a little bit more powerful for a very similar price without any issues at all. I'll cover how some ways to maybe even do this cheaper. As I mentioned, this did not include cases or network. If you want to do cases, you're probably going to add on $10 to $20 if you're buying as cheap a case as you can find. More if you want a nicer case. And that was including, I got some rebates on top of that 400, so it was even less. So what have I upgraded since then? The 250 gig hard drives died, and I bought replacement ones, and then they died. So I said no. And by the time that I replaced them, it wasn't really that much more to just buy 250 gig SSDs. And I'm only using storage on one of the nodes. So I was like, it's cheap enough, I just did it. It didn't really make much in the difference. If you look at current prices now, on smaller hard drives, you can't really save much money on them. SSDs sometimes tend to be cheaper until you get into reasonably larger hard drives than 250 gigs now. I've also split up changed my management storage server to a Raspberry Pi. That was inspired by, after attending a CloudSat collaboration conference a few years ago, as they were talking about that, and there's actually one of the community members that builds packages specifically for Raspberry Pi. So you could do a whole cluster with a Raspberry Pi. I just chose to do the storage and management and then make 2 compute nodes. So that was another 170, but realistically, we probably have some hardware around the house. Which brings me to the next way, where you can save money on this. You could do all Raspberry Pis. It's doable. There are people who are actually doing that now and getting useful clusters out of that. And they take up a lot less space and they take up a lot less power. For some of us, power can be a consideration in California. So you can also, realistically, do you have extra hard drives? How many people here have extra hard drives? Yeah, exactly. You can skip the cost of the hard drives. You can probably end up with a bigger hard drive than I did for less money. There's also probably a few of you that have extra CPUs laying around from upgrading previous servers. Yeah, I see someone there, someone else. or extra memory that you may have sitting around. A few more hands to go up again. So those are some ways that you can take what hardware you may already have. Maybe you only have to buy a motherboard for it or another CPU for it, and make it for a lot less than 500. You can pick refurbished hardware. I tended to stay away from that just because of the difficulty of making sure the hardware is actually reasonable, whether that's a refurbished CPU where you'd have to then get a cooler for it and make sure it matches the motherboard you want, make sure it isn't failed in some way. You run more risks, but you can get them much cheaper than you can new hardware. Same with motherboards. Look at what else if I covered everything. Another way you can end up saving money depending on how current hardware prices are is sometimes it's more advantageous to pick the memory first and start there. Say, what is the cheapest memory I can get for the amount that I want, and base all your hardware on that. I picked CPU in this case, but with how memory prices fluctuate in hardware, you just kind of have to look. But you can definitely save more money there. You can also get really cheap rack mount hardware, especially if you're willing to buy some refurbished stuff. I did find some significantly more powerful hardware than what I ended up building that was rack mount hardware. The problem with that hardware is it's loud. I don't know, I'm sure we've all had experience with that. And at the time I didn't have my own office, it was my wife's office. And putting that loud of hardware was not conducive to keeping people happy in the house. So even though I did find ways to do it, it can be more expensive. You also then need to get a rack for that. And there is why you can buy racks that are expensive. There is a whole group, and I'll have a link to this later, building a rack out of lac tables from IKEA. That worked pretty well. I haven't done that yet. I'm considering it since I have my own office now. Whether I want to put up with that much noise in my office is to be decided. So now a little bit overview about CloudStack. So how do I go about installation? I started with Ubuntu 18.04, and then just had SSH server, sudo, and basic networking set up. One compute node, one management node, management storage node. Later switched to the Raspberry Pi, as I mentioned. I manually set up the networking on those compute nodes. You could do it with Ansible if that's what you prefer. I used Ansible for most of my plays. It's just, if they're sitting in a closet without a display, it can be really hard not to disconnect yourself so you can't fix it. So sometimes it's easier just to do some of that stuff on the console by hand. All their packaging needed for CloudStack I installed with some custom Ansible roles that I did. I didn't pick anything out of Galaxy or roles that plays or roles that were already written because I kind of wanted to dig in to figure out how it all worked, how it all went together. So to force myself to do that, I chose to write my own roles and plays, and I'll have a link to those at the end as well. Then I just pulled that all together with some static inventory for Ansible, as I'm sure there's quite a few people here familiar with Ansible. Some people mentioned that before the talk started. And then I automated purging of the NFS setup, compute, and management, so it was easier. Then instead of going and poking at the database that underlies and fixing that, I figured it was easier just to purge everything and start over, and that ended up being a big time saver. If you have the database knowledge, go for it. But I'm more of a developer on the developer side. Sysadmin stuff is kind of incidental to my development. And so I just didn't, to get all the networking done, I took the easy route. To get all the database done, I figured it was easier to purge instead of to try to dig through the database, because I don't do it enough. I do have some automated source installation and building in those Ansible roles, but I haven't really done it that way. That is definitely the way a lot of bigger installs of CloudStack work, is they're not using the community provided packages. They're actually taking the source and building it from scratch to make sure that it meets exactly what they're trying to do. And then I went through the manual configuration in the web interface, which has gotten a lot better from when I first started on this. The current 4.18, or actually 4.19 now, just released last month, is much, much better. So some of the few of the gotchas that I got with working on this. System VM has definitely been an issue with ClassAct. They've now moved that into the management package. So the ClassAct management, when you either build that manually or you download the community edition, it includes the system VM template for all hypervisors that are supported, which means that package is 1.3 gigs now, which for some of us, maybe we're installing at the end of a relatively slow network interface. That can be noticeable. If you can find a way to cache that locally, there is a way to do that with the Ansible Play, so it's not well documented. You have to look at the source. Just something to be aware of on that one. Networking issues. Custom template creation. So one of the things I found really helpful to do was to customize the template. Those of you who've worked in the cloud before will know that making an AMI, the custom AMI, can be really helpful for having like a base to start from what you're generally doing. But there's a few gotchas. So some of these are going to be repeats for those of you who've worked in the cloud making your own images. In ClassAct, they call them templates instead of AMIs or images and some of the other ones. It's pretty standard. Use CloudInit for all of this. CloudInit supports CloudStack without any problems, supports OpenStack, supports AWS. That's how they do a lot of the initialization when you start up your instance to get set, is done with CloudInit. I've used CentOS and Rocky, but I prefer Debian. And that's usually what I started with. In some cases, I started from an ISO install for the template and just did a real minimal install with just the bare minimum, SSH with a key that I knew or a password, and that's it. And then I have some of I've captured in again that Ansible that I'll link to at the end, of how I prep some of those templates into actually becoming templates. But one of the things that caught me is slash didn't grow. And there were two different reasons for this. Initially, I didn't put the last slash partition as the last partition, which those of you who've done this before will know that just doesn't work. Once I put it the last partition, that worked for Debian and Ubuntu. It didn't work for Rocky. And what turned out to be the case is, for whatever reason, Rocky CloudInit at the time that I did this did not depend on CloudInit utils. And without CloudInit utils, it won't grow. So those of you who are new to this will realize that. Those of you who've done it before, we'll go there. Okay, I'm stopping back a second because I skipped a slide. Networking issues. I took the simple basic networking for ClassAct. They changed the name of it now. I think it's called simple networking instead of basic like it was. This does not include any VLANs. This is just security groups, so just basic firewall for isolation of guests. ClassAct does support VLAN. It does support VXLAN. It does support some SDN solutions as well. But I'm not a network engineer. I'm just, without that experience on doing the networking, it can be quite hard to get that all configured. If you're more of a networking engineer, go for it. Go buy yourself a Cisco switch, and you can get VLAN isolation and all that stuff working. I took all of the 10/8 because I wasn't using it on my home network, just dedicated the whole thing to ClassAct. I don't use anywhere near that number of IPs, obviously, because I don't have enough instances, but it has been useful to keep it separate from the rest of my networking. The first problem I had is getting the bridge networking set up correctly. The compute node needs to have a bridge networking for all networking that your VMs may connect to, which includes the management network, which is how ClassAct talks to all the different instances. Includes any storage networking so that it can talk, so that it has a system VM that comes up that manages the access of instances to all the secondary storage and primary storage. That needs to have a bridge so that works. And then the guest network. In my case, I just stuck everything on what's effectively a public IP address, which is just an IP address that's accessible from the rest of my network. There are ways to do guest isolation with VPCs, just like you do in AWS, Google, Azure, OpenStack. I just chose not to do that for my home networking. The second thing that keeps catching me, I keep forgetting about, is that the pod networking, the IP space that you set aside for the pod during setup, is the networking space that all of the networks need to fall under. The management and the storage and all that. Because otherwise it doesn't get set up correctly. I keep forgetting to set it that way. I'm sure someone else will do that. One way you can tell once you have it running and you've gone through your first step of configuration is CloudStack as of 4.19, it still does this. There's talk of changing that. It downloads a CentOS template that is ancient, but once that template downloads and you can see it on your network and you can see it in your cloud, you know that you've gotten everything set up correctly. The most common issue I ran into is that I typoed the storage network and then it wouldn't successfully download. And it will tell you when you go in there. I don't have examples of that today. Talked about custom, okay. So now to talk about what did I use my cloud for. A big one was Ansible testing, as some people mentioned before starting up that they've used Ansible. I don't know how many people here have. A few. It has been very useful having instances that I can just spin up and spin down that generally better match actual installed servers that I've been running since, in some cases, long before Ansible was around. In other cases, I just didn't configure them with Ansible to begin with. Having ones that instances I can spin up to test roles or to go back and say, you know, I really want to capture my DNS configuration to make sure that I can push it out to other servers has been really, really useful. Much more useful than I expected it was going to be. I've also tested quite a few different distros, whether that's different versions of Ubuntu or Debian or Rocky or Alma or CentOS, or I think I even stood up a Nix template at one point to mess with that, or Nix. There's another one that I've set up a few times. And then I also did some testing for potentially building a custom NAS for home, and it was actually useful. Granted, the storage is a little bit limited, so I didn't have quite as much storage to do a full test, but it was enough to get an idea that, hey, do I want to do true NAS? Do I want to do Open Media Vault? Do I want to do something else? It was surprisingly useful even on something like that. I've also generally started testing most of my services that get put on the home server in the cloud first. So before I actually set up Plex for real on an actual server in my network, I ran it in CloudStack, and that worked perfectly fine. It was not perfect, mostly because, again, storage space, because there's only a limited amount of storage I have, but also because I picked cheap processors, and if there's any sort of transcoding, not going to work. But that's plenty to get testing done. It's plenty to get an idea of what's going on with Plex. It's plenty for direct play. Setting up WireGuard for a VPN setup, that was really useful to do that before I put it on my main server, because I don't really want to disrupt my main server because that breaks stuff for the rest of the network for the rest of my house. And when I break stuff like that, people do notice in my house. It's unpopular. Sometimes it's nice to have somewhere you can set up like QMK building or some other development, maybe Rust or something else, before you put it on your main development box, because you may not want to disrupt whatever you're doing on that development box, or make sure that it's not going to disrupt what you're doing, and that's turned out to be pretty helpful. There's also been some instances where having a dev node I can just spin up and throw away is surprisingly useful, besides just services. Like, why is my particular version not building correctly? I can put on a specific version of GCC, I can put on specific versions of Make, I can do whatever debugging I may need to do of my build environment itself without disrupting other stuff that is working on my main dev node, and that's saved me an invaluable amount of time. Learn from what I did. So my biggest lesson, I think, is that the CPUs mattered much more to my use cases than memory. Like, I haven't had any real problems with memory other than, I don't think I really have. It's really a matter of the CPU and not having enough cores. Most of the stuff I'm testing isn't really memory bound. It's usually CPU or disk bound. And that said, the Raspberry Pi is, for the hardware I have, it was comparable. Once I put the storage in a dedicated actual USB 3 hanging off of the Raspberry Pi, not trying to serve off of the SD card. Those just aren't fast enough. Once it was in its own, once it was off the USB 3, the performance between when I had the storage on like one of the nodes I started with to Raspberry Pi is almost unnoticeable. It really didn't make much difference at all, especially with the new Raspberry 4s. Raspberry 5s I expect to be even better. As I was mentioning, memory just hasn't been as critical for what I'm doing. I'm not doing really memory-intensive testing in there. Now, if you are doing something different, that is something to consider. Maybe you do want to do GPU sharing, which CloudStack does support in some instances, to do LLM AI development or something like that, or you're doing large databases, or you're trying to do memory caching or something like that, where you do need more memory for doing some of that stuff. It's perfectly reasonable. Spend the money then on getting more memory instead of more CPU. I just found that for most of what I do, 99% of what I've done, it's really been limited by the CPU cores, not the memory. Something to also keep in mind, which is going to be kind of repetitive because I'm sure all of us have heard this before, is back up your stuff. Whether that's your template that you spent all that effort building in the cloud, back that up somewhere outside the cloud, so that if that way you can treat your cluster as what you can reinstall it and you don't care. You just reload the templates. It's not a big deal. Also keeping any like ISOs or additional templates that you're not actually using outside your cloud somewhere else where you have more storage, especially when you're limited with the storage space, like if you're building this in as cheap as you can and you don't have that 2 terabyte drive sitting extra unused. Keep those out of the cloud too. Once you build your base template from an ISO, don't keep the ISO in your cloud. Once you build a template and then you update it to the newest release of that version, don't keep the old versions around. It just wastes space. You're not going to go back. Unless you have a specific reason, you're just not going to go back. As many of you are going to be familiar with this, if you worked with the cloud at all, keeping your templates, your machine images, your images, as small as possible helps a lot. And it's not just in how much storage space it takes up, it speeds up your instance launching a lot. The bigger your template you're starting from, that has to be copied, and that slows stuff down. And the smaller the cluster you're running on, the more noticeable that will be. Is there any questions so far? Comments? Sure. Here. He got one first, then I'll get to you.
So CloudStack seems to be like a so I use Proxmox at home. So
Yes.
I kind of do the same workflows with Proxmox. I just whip up a virtual machine, install a Ubuntu server on it, and then do that testing that I do in there.
Proxmox can do a lot of the same stuff CloudStack does.
Okay.
The advantage of CloudStack over Proxmox is that CloudStack can scale bigger than Proxmox can.
So I can
and
have
it's a
multiple
full
nodes.
cloud.
Okay.
Like it's not like it's not just VMs. Like there's image management, there's auto scaling of some sort you can do, there's migration between hosts, there's now managed Kubernetes clusters since 4.18. I haven't run it. I haven't run that particular stuff because I haven't had a need for it yet, though that's what I'm going to look into next.
Okay.
But it's a full cloud. So Proxmox can meet a lot of these
Got it.
a lot of these things, especially with some of the nice I think they have some web-based interfaces now.
Yeah.
Yeah. No, there's definitely overlap with some of these. It's just I don't think you're going to run 1,000 instances on Proxmox, and you're not going to do migration between zones. You might not, because you can set up multiple zones, kind of.
Yeah.
The CloudStack uses some different terminology, but you basically have different regions and different zones, and you can migrate between them, and there's a bunch of that kind of stuff. Does that answer the question?
Yeah. Well, actually, I have a second part.
Okay.
So I assume the Raspberry Pis I assume are running containers, and then your x86 machine that can run VMs. So you manage all of it through CloudStack.
So on the Raspberry Pi management storage node, it's just running the OS.
Oh,
it's not running containers. I'm not running any virtualization or anything on that. It's just running Java. Most of class acts written in Java, so that that's pretty easy to deal with. It's just the compute knows that do stuff.
CPU definitely matters in a ton of applications, but there are some applications that are extremely memory intensive. I encountered while I was building a self-hosted map and routing server.
Oh yeah.
Routing 100% lives in the RAM. So
Oh yeah, especially
you need
perform it.
if you want a map for all of North America, you need like 100 gigs of RAM, and there's no two ways about it. So some applications, read the docs, guys.
I'm curious as how you hooked up the storage to the Raspberry Pis. Are you using like a USB hard drive interface?
Okay, yeah, I can talk some more about the storage on the Raspberry Pi. So what I did is I have an SSD that's sitting in the most performant external device I could find for Raspberry, for a 3.0, USB 3.0. You're not going to get the best performance, but for the hardware I was using to begin with, it really isn't any different. It's been more limited because the hardware I started with, I mean, you saw that I spent less than $500 shipped. And that hardware compared to the Raspberry Pi is not much performance difference. Now, if you're optimizing your hardware for storage more, you can get better performance than the Raspberry Pi can provide. But if you're doing this on the cheap, for as cheap as you can, it may not be as big of a difference as you think it was. It sure turned out to be the case once I started doing it. I expected it to be a problem, and it was a problem when I ran the storage off of the SD card. But once I moved it to its own USB 3, it wasn't really a problem, which kind of surprised me. And as someone was mentioning about the networking, yes, depending on the type of stuff you're doing, it will make a big difference. Memory may be a much more limiting factor than anything else, particularly with routing, or if you're doing some software-defined networking, which CloudStack totally supports, but I would expect that those routers you'd need to have configured and running are going to take quite a bit more memory than what I may have set up. But you have to take that in consideration when you're what you want to optimize your cloud for. And if you're building it cheap, you can always start with the less $5, or much less if you have the hardware laying around, and upgrade later. Get started, try it, see what happens. So one question is, did I spend less than AWS? At the time I did this, definitely after about 5 months, I was definitely way less than I would have spent for a similar set of instances. It's a little harder to tell now because some of the stuff I did in CloudStack you can now do cheaper in AWS without actually having instances. So that changes some of the calculations. But a rough idea was, with what I did on average, was probably about $50 to $70 a month. So it takes around 10 months for my investment, assuming like I'm actually spending $50 in instances. Advantage is you don't have to worry about shutdown termination to save money. You don't have to worry about any extra costs for storing AMIs. They're effectively free. I already bought the storage. So I could have custom AMIs for as long as I wanted. It didn't really make any difference in my cost. Where in almost all the clouds, there's some cost for storage. And after it's been running for so long, really the main cost on my stuff is electricity, especially being SDG&E's region. I can see some of you shaking your heads, so I'm assuming you know what that means. But yeah, electricity is by far the biggest driver of cost right now for me. And also to be aware, there's some testing I couldn't do in the cloud. Like if I was going to try to test Plex, for one example, the smallest DVD I have is 3.4 gigs. To move enough of those into the cloud to be useful, it's just not going to happen. It just isn't. And the cost for that kind of storage is just way too high. Where I could reasonably test it, I didn't have maybe 2 or 3 DVDs and a Blu-ray, but it was enough to test it to say, yes, this is something I want to put on my network. Yes, I want to start managing it. So it was useful and ended up saving me money. Some final thoughts. One thing that will take a surprising amount of bandwidth, especially if you're installing multiple different Linux distributions, is packaging. I would strongly suggest something to limit your bandwidth, or you will notice some issues. I don't know how many of you are running any sort of package caching like app cacher ng. That's what I've used since I'm mostly a Debian Ubuntu guy. But that makes a really big difference on how fast a turnaround you can have on spinning up your templates and getting them to a reasonably recent set of whatever the recent security updates have been. RPMs have similar solutions. You can configure app cacher ng to cache RPMs, but yeah, I would strongly suggest that you have some sort of package caching. It'll make a big difference. It makes installing instances, even VMs probably in like your Proxmox, having something there that you, like I baked it into my template that it points at my local app cache, so that when I spin it up, I can run an update and it's going to update in maybe a minute or two instead of like however long it takes to download all those updates. As I mentioned before, keep templates and ISOs and whatnot outside your cloud. Once you build up a template from your ISO, doing maybe a base install, because you can get to the console in CloudStack, there's support for that. You don't really need to keep the ISO around. Just keep the template. Depending on what you're doing, if you're finding storage is becoming a problem, first of all, don't use the cheapest hardware you can, whether it's a Raspberry Pi or what I did. That will definitely make a big improvement. Also, dedicating a storage for a switch for some of that storage can make a big improvement. If you think you're going to need a lot of, like you're going to move a lot of data, or you're going to be doing something that's very disk intensive for your type of use case, start looking at what some of the other options are other than NFS, or maybe splitting up your secondary and primary server, your primary storage, so that your primary storage is on the fastest possible way, or maybe you use local storage, which will make it harder to migrate instances, but you can specify CloudStack to use local storage for VMs. It just slows down your migrations a lot. The VLAN tagging and trunking, I'm now looking into that, not for my home cluster, but for a different one. Definitely takes a lot more advanced networking knowledge than I have, but having at least some idea on that can make it much easier to talk to your network engineer who's configuring your switch, if you have that ability. But it's also not unreasonable to buy Cisco or whatever, I don't know what people are buying that are full layer 3 that can do VLANs, because there's a lot of power to be had there. And as mentioned previously, is that CloudStack does support some SDN, some software-defined networking. That seems to be somewhat in flux. Not that CloudStack isn't going to support it, but there seems to be some talk of resurrecting some dead SDN projects now that VMware has been bought by Broadcom and has changed licensing models. There's some doubt for some of the SDN stuff that they've supplied previously to continue to be available. So I just kind of, if you're interested in that kind of stuff, keep your eyes open, because there's been some discussion on the list, at least one or two threads about people talking about that they're trying to get a group together to resurrect. I can't remember what the SDN tool was that they're talking about, but they're talking about resurrecting that. So that would be useful if you're looking for that. It can also be really helpful to have an SSL cert for your CloudStack. On my home networking, it's my own network, but I still try to keep everything encrypted, because if someone gets in, it makes it that much easier for them to get elsewhere. And if it's encrypted, it makes it much less likely. And more likely that I will see something that looks wrong if it's harder. I did that by pulling Let's Encrypt cert. And generally, you can't pull certs for privately routed DNS, but there's no reason, if you have your own DNS name or your own domain, there's no reason you can't set up either a wildcard cert of some sort that you can get from Let's Encrypt. You do have to do some DNS authentication, but you can automate that with Ansible if you spend enough time, or SaltStack or whatever, or Chef or whatever you want to. But I did that, and that definitely helped. There are some addition, or maybe even setting up an Acme server for testing. Maybe you want to try doing an Acme server with SSL signed certs and automate pushing certs onto instances. That's definitely something doable with this. As I mentioned, I think in passing earlier, as of 4.18, CloudStack has added a managed Kubernetes cluster that also supports the cluster API. And I've seen someone live demo this at a presentation. I was very impressed that they were able to do that, where you basically just have your base Kubernetes cluster somewhere. You tell it where you want to deploy, and it'll just deploy and automatically set up the whole cluster in CloudStack. I have not looked at that yet because I just haven't had enough need, but in 4.19 there's some additional improvements with that. Just came out the end of February. That looks pretty good. It's a fully managed cluster. It supports CAPI. It supports one of the other APIs I think that's common in Kubernetes. I haven't looked at Kubernetes enough to speak to it, but yeah, it's there. And as promised, here's some of the links. You can reach me at that email, either one of those. The presentation will live at that Google Docs address if you want. Take a picture, as many of you already are. The CloudStack roles, those are the ones I'm currently using for my own private cloud and for what I'm doing for work. It is not, don't take it as a really good example of Ansible. Some of that Ansible I wrote in there is very early from what I've learned now. And I just haven't gone back and rewritten it. There's also been some changes with how you should be doing some stuff in there. Namely, your module should boot fully, the full name of the module. Some of you know with Ansible. There's stuff like that that's still in there. But yeah, you're welcome to look at that. And then as promised, the rack page. If you're thinking about rack hardware and you're trying to figure out how you're going to put it, mount it somewhere, and you want to do it on cheap, those rack tables look really good for that. And unless people have more questions, I think that's it.